Okay, we're going to build a simulation of the way light bounces into a coffee cup or a teacup and makes those amazing shapes you can see at the bottom of your teacup or on the top of your coffee or whatever it is. I want to try and recreate what we see in real life by modeling it in Geogebra, but I'm going to do some maths to build it, but I want to sort of let the physicality of the way light bounces make the shape rather than guessing the mathematics of the shape, which we could also do later. Anyway, let's build the thing first. If you're here from the Numberphile video, welcome. If you're not, it might be worth watching. Anyway, let's build the thing. I'm running Geogebra Classic 5, and I'm going to start by making a circle because this is going to represent like a coffee cup or at least something which the light bounces off. Maybe the inside of my ring, which was a good demonstration, is nice and shiny, a gold ring, but a coffee cup seems to do it really well. So we're going to center on the origin. Let's go radius 1 for want of anything better. I already realized I don't want labels turning up, so let's turn off the labeling. No new objects, and we'll turn off the label of that, but it is called C. That might be useful. The other thing we need here is a source for the light, so I'm just going to make a point A. It could be anywhere, and I'd like to be able to move it around later to see where moving the light source is, how that affects it, but that's going to be my light source. Let's leave it called A, that's fine. And I guess my first job is to simulate the light coming from a point source like that towards the circle. And my idea is that we're going to make a bunch of rays, or probably lines, to be honest. Rays is a command in Geogebra, a line just in one direction. In the end, I just want to show line segments. I don't want to show it going off to infinity because I want to hit the edge of it and bounce back. But having the lines gives me a way of finding where they go, and then I can sort of just crop it down to a segment. I think that's what my plan is. I also don't need to send rays or lines towards bits where it will miss the circle. So what seems obvious to me is I need to figure out where lines that go through this point are tangent to that circle, and that's going to be the limits of the lines I need to draw. So let's try the word tangent. There we go, point and conic. So I'm going to say the point A and the conic C, and it's drawn the lines I wanted. Now I'm sure there's other ways of finding those tangents. There's a button for it up here. In fact, there it is. We've done the same thing, I think. But I think this is what I need because this is going to auto update. I probably want to know these points, and I could do that with an intersect command. The trouble is with the intersect command, it's looking for intersections, and those points don't technically intersect. They touch, and I suspect that might cause us glitches. So I'll find those points later if I need them. I could just intersect those lines with the circle and I'll probably get the points, but I might not need them. So my job is just to get a bunch of lines coming from that point that head towards the circle, so lines in between those things. I think what I'm going to do is rotate one of those lines at lots of little steps, according to how many lines I want, up to the other line. So actually, let's bring a slider in. Let's call it an integer n. We'll let it go quite high. We can change this later, but this could be the number of lines lines of light we're going to use from this point. And so we'll go straight into a list command, a sequence command, which will generate a list for us. The sequence command is really powerful for generating just sequences of numbers, but more powerful when you use it to generate lists of objects. In this case, it's going to be a list of lines. So let's use the line command. In fact, I've already got a line. One of these lines is F or G. That's the bottom one is F. Okay. It's not obvious to me how it's labelled. We'll call them F and G, and I don't know which is which. Now, I'm trusting Geogebra to handle them, keep them separate, but weirdly, the command for both of these was the same, and it's created two outputs, and that's slightly mysterious to me. But I'm just going to trust that it's labelled them. So let's just say we're going to take the line F and we're going to rotate it. Rotate F by some angle. I'm going to start using some dummy variables here. K is going to be something I'll increase in this sequence, but I want the angle between these two lines, so let's do angle between two lines. Look at that, F and G. That's the angle between them, whatever it is. And I want to split that into n bits. So you can see I've got lots of things going on here. I've got the angle between F and G. I've got the dividing by n, which can change to be how many steps to do it in, and then K is the thing I want to run through. I think that is it. So we're going to let K advance from 0, which will give us that first tangent line repeated, and up to n. What have I done wrong? Okay, right. It is rotating line F, but I haven't told it what to rotate around because the rotate command doesn't necessarily ask for center of rotation. So it's going around the origin. Let's tell it to rotate around the point A. Right, that's what I was expecting to see. It's being clever with the command. If you don't give it a center of rotation, it assumes the origin. But I need it not to be the origin. So that is promising. Let's press return. And I could probably hide those tangent lines now because they're going to get recreated, and then that's cleaner. That's already really nice, isn't it? Those lines are heading towards the circle. I've got no redundant ones. And what's left is to figure out how to model the bouncing. And I can do all the prettification and the colours and things. And that is quite important because this is about how light stacks up and overlaps. And I can play with the opacity to make that work. But let's just get the lines appearing first. And does it work when I change it? And that's nice. Okay, that is doing it. So there's 1 line, 4 lines, and so on. Let's leave it lowish so we can see what's going on. So what I think I'm going to start doing is creating lists of things. And the first one's called L1. I'm going to rename this something sensible. Let's call it lines. So they are full lines. They're not the segments or rays for that matter. But I feel like I'm going to create more lines. So this is the first list of lines. And I guess the first thing I'm going to assume is that it doesn't bounce off the first edge of the circle because it's kind of coming in enough at an angle to bounce off, which is what happens when your coffee cup is sort of underneath a spotlight and the light's coming in like that. I do need, though, to get these endpoints. So I need the intersections. And this is where I'm slightly worried because the intersections of these lines in the circle, there are 2 of them. I need to tell it somehow which one I want. I think there's a way. So we're going to... there's loads of sequence commands. This is just all sequences. And the zip command lets you run through other lists, sometimes more than one at once. We're going to use it a lot in this. And what it wants is an expression with some variables in it, but it's going to get those variables from the lists I tell it to, and it's going to run through those lists. In this case, I want to get the intersections of a line. Let's call it L. L doesn't exist, and it's just a dummy variable. I'm going to tell it which list to get the L's from, with the circle C. But the intersect command can have another argument. Let's see if I can get that up again. Here we go. So there's object, or there's object, index of intersection point. And I think that tells me, like, it's if there's more than one, it will label them 1, 2, 3, and 4. Now, I don't know which is which, and a line doesn't have an orientation that I can really tell about. So we'll guess a little bit. But I'm going to say the L intersect with C, and we'll just say 1 to start with and see which one it gets. The line is going to come from the list I just called lines 1. And I don't need to get any other variables in here. So hopefully this will make some points. And it's made the first intersection point. I guess that's not a surprise. But it's first from left. I don't know if it's counting left to right. Anyway, let's change it to 2 and see what happens. And those are the ones I want because they're the ones it's bouncing off. Now, it's not picking up the intersection points at the tangent lines. Now, that's fine. The light won't bounce there. But they are intersection points, so I don't know why it's not picking them up. And these are edge cases, literally, in this case. So I'm not going to worry about it. But I am puzzled there. However, this looks like it's doing what I want. Those are the ends. And I can see it's got a question mark at the beginning because the first line doesn't appear to create an intersection point. I'm not worried about it, but it is odd. Stop stressing, Ben. It's working even when I move it around. So far, so good. Oh, something weird happened then. The intersection point just turned up. There it is. Did you see that? I thought something weird was happening. Occasionally I can make this glitch and the point appears up here. I'm going to choose not to worry about that and solve that later. If I don't solve it later, please write in the comments about what you think is going on there. First thing though, I've got the points. I need to bounce those light rays at an appropriate angle. And to do that, I could create tangents at all those points, tangents to the circle, and reflect the line in that. That would work. I could also create a normal at that point and reflect the line in that. I think that both would do the same effect. The normal though is dead easy because it's a line to the radius. It's a radius line from that point to the center. So I think that's the line I'm going to do. Let's try and build some new lines, which are the lines that the light would reflect into. Now I wonder. What I'm tempted to do first is actually turn these lines off and just create line segments, so I've only got the bits I want. And in fact, let's keep my naming habits. Let's call these the ends 1, because it's the end of lines 1. And I'm going to create a new list called paths 1, which is the light paths I want, not the full line. And I think that's, once I've got the endpoints, that's fine. I've used the lines 1 list to get those endpoints. So let's use zip command again, and I'm going to run through a segment this time. Segment from A, the source point, to some point P using a variable not defined, it's dummy variable, and just take the P's from ends 1. Okay. Looks like it's working already. That's what I want. I think that's what I want. Oh, occasionally that one turns up on the edge. I'm not going to worry about it. I said I wasn't going to worry about it. That is what I want though. So now I've got sort of the version I want to display. In the background, the lines are doing the whole thing, and that's useful because I didn't know where they should have ended until I got those ends. But now I've got the ends, I can turn them off, and I've just got the paths to that point, or to the endpoints. So let's figure out how. I guess it's going to be a new list of lines from which I can create endpoints and then paths again. Let's try and make lines 2. Okay, there's going to be I feel like once we can do this, we could do it again and again. So let's figure out how we're going to do it. We're going to zip, and we're going to create lines. Line from point to point. No, I'm going to I'm not going to create lines. I'm going to reflect a line. Think about it, Ben. Reflect a line. It's saying reflecting a point. You will have noticed there was reflecting a line. So reflect the line L, and I'll grab the lines from lines 1. I can do that now, can I? L from lines 1. But this time I'm going to use zip command to use another list as well. You can see there's any number of lists in there if you want. There's a ... We could have lots of lists, but I think I'll only need 2 because I want it to not use a point. I want it to use a line, which is defined from a point. So it's the line that goes through the point P, which is going to grab from the endpoints. Let's put that in. P from ends 1. But the line needs to go from the point P to the origin, which is the middle of the circle. So let's just call it 0, 0. Ooh, it's done it. There's the advantage and disadvantage of putting those lists in as I populate it. It keeps me on track, but it also is previewing it. Now, if I was doing this incorrectly and it was doing something way more complicated than I wanted to do, maybe I don't want that preview. I don't know how to turn that off. I haven't pressed return yet. I'm going to press it now because it is looking like I'm doing the right thing. And already we can see the behavior that I kind of wanted to see. That caustic effect is turning up. When I have fewer lines, it's much less obvious. When I have lots of lines, oh, look at that. Now, we've got problems that it starts to block itself out when it's too opaque like that. But let's do the tidying and get the paths, not the full lines. But I think that's doing what I needed. So that's lines 2, and I've kind of got my protocol now. Let's get the next set of ends, because I need the segment to go to that end. So ends 2. It's going to be a zip again, intersect lines 2, the things I just made, with the circle C. Oh, yeah, but which intersection point is it? Well, let's try 1. And we'll get... it's not lines 2. I need to send it a line from lines 2. L from lines 2. There we go. Get the protocol right. Delete the rest. We should get some points appearing. I think those are the points I want, because there's some appearing over here. I didn't expect the 1 command to do what I wanted. I was expecting it to be the second intersection, but don't complain if it's doing what you want. Let's check. The real test will be if I make paths between the ends 1 and ends 2, whether I get the paths I want. So let's turn lines 2 off and build the paths, which will be paths 2 equals zip segment P, which I need to get from ends 1, Q, these are both dummy variables now, Q from ends 2. That feels pleasingly logical. And it works. You can tell I'm more pleased than I expected about that. Good. Let's crank it up. I already want to play with the visuals already, but the functionality is doing what I need. I don't need those ends points. That's good. You can start to see some of the things I talk about in the Numberphile video. When the light source is close, you get a cardioid shape. When it's far away, it's more like a nephroid shape or half of a nephroid shape. We could make A just go really far away. Let's just type in a value. It's negative 100, 0, way off the left-hand side. And they'll start to look like they're coming in parallel, and that's the nephroid shape we're talking about. And let's bring it in close. Negative 1.1 cardioid shape. Nice. We could do a button to do that sort of thing later on. Just a button that has set value A to be whatever you want it to be. And that would be an easy way to make a user interface for that sort of process. Okay, it'd be nice to get a second bounce, and it'd be nice to make this look better. So let's do some of the aesthetic stuff. First, I'm going to make the background black because light things show up better on dark things. Let's just go almost black. The reason I don't go full black sometimes is that if I've got black things and I've forgotten about it, it's quite useful to be able to see them still, like this slider, which would have completely vanished. I probably don't need the grid on. I can just about see the slider, but let's just make the slider white so that we can see it again. The circle should probably be white. Maybe for the same reason I should go almost white, so that if I make the background white again, it doesn't vanish. Do what you want. Now it's really obvious that when this cranks up, and we can let this go higher, but if it goes too high, we're just going to get a wall of green light in this case. Let's go up to 500. But I don't think it's going to look very good. Yeah, it's terrible. So what I need is these light rays to simulate light a bit better by being translucent. But that's fine because there's every object in Geogebra has a opacity property. And I've got two of these, so paths 1 and paths 2. Let's make them both. Let's make them yellow for light and style. Line opacity, let's take it right down. If I make it 0, I think they'll disappear. So I'm going to make it as low as it can go. And I can change the thickness, that might be important as well. But now, it looks weird here, but things get highlighted when you select them in Geogebra, so it's worth clicking away to check what things really look like, and it looks very different. When I haven't got very many lines at all, they're very difficult to see. But if I crank it up, and this is the effect that I enjoyed showing Brady in the Numberphile video, and it's actually doing what light does. There's loads of lines which are very faint, but when they do overlap, because their opacity sort of like builds up, that's when you see them better, and that's what's happening with real light. Now, there's not a finite number of lines of real light. Then we're modeling these with finite numbers, but this is kind of, by the time we get to 500, you can't see the individual lines, and where they overlap gets super bright and get that lovely glowing effect there, which is genuinely what you see. And so I'm really pleased that this model sort of does what you want it to do, simulating the real world nicely. And it even moves around pretty successfully. You can see the lines when you're getting close, but they vanish when you have a light source inside because of the way I've built it. Okay, great. Let's calm it down and get the second bounce. I feel like I've got the protocol. I've got lines 1, ends 1, paths 1, lines 2, ends 2, paths 2. Let's go lines 3, shall we? Now, lines 3 is going to be almost certainly a zip, and we will create lines. Now we're going to reflect lines. Right, I need to get the endpoints then. So let's reflect a line L, which will come from lines 2. Good. In a line which goes from the origin to ends, the ends in ends 2. 0, 0. I wonder if doing the opposite, I can't remember which way around I did it before, we might get a different intersection number from doing it the other way around. I'm just going to deal with that. I could go and look. What did I do before? I did P00. Let's do it the same way round for consistency. But this time P needs to come from ends 2. I can't see them. Didn't like it. Unbalanced brackets. Let's go and have a look through. I've closed the coordinate, I've closed the line, I haven't closed the reflection. Ooh, that's done something. And I think that's done the right thing. They're not looking nice because they're still really opaque and they're horrible green colour, and they're not the paths I want. And to get the paths I need the endpoints again. So let's just go through it and then prettify it. Ends 3 is going to be a zip. Intersect, just like before, the lines from lines 3, the one I just built, and the circle C. And what index? I'm going to use index 1, and again, we'll see what it does. Okay, they are turning up. They're harder to see because of the colour change. And it's really hard for me to see if they're the ones I want. Let's try 2 and see what happens. They're there, and they look more familiar. They look like the ones I had before. Let's go with 1, which is what we did last time, and just see what happens. Turn off the lines. they look like ones I haven't got paths to yet. So let's do the paths. Paths 3. No, don't make a slider called paths 3. Delete. Paths 3 equals zip segment P and Q, P from ends 2 and Q from ends 3, the one I just made. Is that what I was expecting? I think that is what I was expecting. Isn't I was going to say that's the one I built before, but it is the one I built before with lines. Now I've built it with the paths, and that's what I wanted. Good. Okay, let's make that look a bit better. We can make that one yellow. Oh, bright yellow. Nice. And very transparent. I think I had it at the lowest setting. Did I? Let's check. Yes. Crank it up again. Nice. I don't need those ends to appear. Let's hide that. And there's the second bounce. Now, I think maybe it's useful to see them in different colours. So let's do the paths 1. Paths 2 can be red. Nice. And paths 3 can be some sort of better green colour. And now we can see yellow light coming in. Red first bounce. Green second bounce. That's nice. Maybe I don't want green. I'm not sure I like the green. Get some bluey colour. Oh, that's nice. Blue and red's a good combo, isn't it? And this is working. I've got 2 bounces of the light inside the thing, which you don't really see unless you sort out the lighting really carefully. That's lovely. I like it. This is the basic idea of what I'm doing to model the caustics inside the circle. And I hope you see that I didn't need loads of maths to work this out. I'm just literally sort of treating Geogebra as a physics modeling thing by making things reflect off a circle, which is easy enough because the command's built in. Now, there's a lot of list commands to handle, but once you've got the hang of sequence and zip, super powerful. The one other thing I'd really like to do is make this animate. So make the light appear and then head off and bounce. So you can see kind of the order the light goes. You never see light traveling that slowly, but it'd be nice to be able to slow it down and see that. So let's treat that as our next goal. Okay, the animation I think we're going to achieve by exploiting a property in Geogebra that every object that has some sort of length dimension to it, you can put a point on it. And you can put a point with a parameter which goes from 0 to 1, 0 being you put it at the start of the object and 1 you put it at the end, and you can smoothly change that parameter to go between and it will move along the object. It's quite a useful way to animate things. The catch is here that all of my path lines are different lengths. So if I made a bunch of dots move along them from 0 to 1, they'd all get to the end at the same time, and that's precisely not what I want to happen. I want them to go at a certain speed. So I'll have to play with that a bit. I'm going to tinker by just getting a slider. Let's call it T for time. Let's start it at 0 and let it go high. I don't really know how high. Let's say 20. I don't really know what I want here. I'll make it increment slowly so we get a clean animation. Oh, it's black. Nice. Let's make that. Great. Okay. Doesn't do anything at all. But I want a point to start appearing from the light source and head along as I increase time. It'd be good to experiment on one line, but they're all buried in a list, so we'll go straight in with the zip command. Let's zip through that first bunch of lines. I would like a point on an object, not L. Let's call it lowercase p. I'm going to confuse myself. P for a path with a parameter. And how do this is the tiny bit of thinking I have to do. I want that parameter to be 0 when time is 0 and the same length as the path when time is, well, let's go with 1 for now. Is that what I want? Or rather, I need it to become 1 in there when time has reached it. The point I'm trying to make is if I just put t in there, when we get t equals 1, they'll all reach the end of the path. So we need to scale it by the length of the paths. But the length of the paths are just written in this list here. So paths 1 is a bunch of line segments, but the numbers of that object are just the length of the paths. You can see the first one's 2.42 and the second one's 2.47, and it would carry on. So I think I just divide the time by the length of the path. Let's call it S for segment. Is that right? No, it's the same path. It's the P, and P is coming from paths 1. But it's weird. I'm putting a point on a path, which is a segment, and then using the values of the path to get its length. I think that will work. I mean, it's made some points in a black band there. Let's have a play. First of all, let's make them yellow so we can see them. Maybe let's reduce the number of lines. There they are. Okay. Whether it's by luck or judgment, I think we've done it. So when t is 0, it's starting there and it heads off and it reaches the end. It feels like they're moving at the same speed. And if I just put t in there, let's try it. If I just put t instead of dividing it by p, I think we'd have seen a different effect, which I didn't want. Right, they all reach the end at the same time, and that's not what happens. So let's undo that. Undo it more. Okay, it's come right back to that. I think that is fine. Okay, so that's good. It's just that scaling catch. Like, it's easy when you know how, but just knowing to divide by p, and I'm using the paths as segments and as lengths, and that feels lucky. I'm exploiting the way Geogebra stores these objects, perhaps. The difficulty is I'd like to get the bounce now. So what am I going to call this list? They're like partial paths, aren't they? Or the ends of the partial points. So are they partial points? Partial points 1. And actually, I don't want to show the points. I want to show the segments extending to those points. So let's hide the points. More lists. Let's call them partial paths. Another zip. We're going to run a segment. In this case, spell segment correctly, Ben. From A, the light source, to a point P, but P is the work we've done from partial points 1. Nervous delete. Oh, there they are. There are the light rays, and it looks like they will extend nicely. Light is coming in and it hits the edge. Cool. Okay. Easy step done, I think. How do we get the bounce? Well, I can use the ends and the previous paths that I've done. It's just they're all happening at different times, so I have to sort of compensate for the time. Let's have a think. And first of all, let's get the end points after it bounces. So partial points 2. Zip. I want to get the point so I can get the end point of the segment. And it's a point on the object path 2. So let's get P and then some parameter, which I'll get in a minute. So but P has got to come from paths 2. And if it was just like the first one, it would be T divided by P. But I need the total length of the path. How do I want to do this? I need to compensate for the time that's already gone. But I need it to be sort of moving proportional to the path it's on. So I'll tell you what, let's just factor out the time that they will finish their previous one. So instead of time, let's do t minus, I need a new letter. I'm going to use s. And s is the length of paths 1. So for each one of these, we're going to is it doing it already? Let me think out loud before I get distracted. I'm going to be doing the time, take away the total length that it's taken to get to the end of the first path. But that new time, which is just like scaled, like, so since the collision, we're going to scale by p from paths 2, so the length of the new path. I think that's right. And I just need to get the length of the old paths from paths 1. It does look like it's doing something approximately right. Let's press return and see what happens when I drag it around. I think it's working, you know. So they come in and the points start moving when the rays hit it. And I can imagine tracing those points to create the underlying structure. Well, let's try building the partial paths. I've called it partial paths and I need partial paths 1, but never mind. Partial paths 2, zip, segment, P and Q, they're my standard dummy variables for points, and P from ends 1, but Q needs to go to the points I've just made, the partial points 2. Looking good. Let's turn the points off. Now, it's a bit jerky because I've got way more time than I need here, but I do need T to sort of be long enough. I don't know how long T has to be. I guess it's the total path length that has to go through. And we can actually we could work that out, couldn't we? the paths I've built are paths 1, 2, and 3, so we could just add them together. Paths 1 plus paths 2 plus paths 3. It should make a list. Like you can do list functions like this sometimes. And actually I want the maximum of that. L1. Let's call that total paths. Obviously if I wanted another bounce I could add that in as well, but 2 bounces at a time. Maximum, not in the list, total paths. Didn't like it. Remove undefined. Look, remove undefined is a very useful command. Let's remove undefined from total paths and find the maximum. Doing that all in one step, that's probably stupid, but that worked. Okay, so long A, we've got B now. That's going to be max path. And maybe we can use that to define how far T needs to go. I've got the second bounce in there, which I don't need yet. Huh. Did I not add together path 3? Oh, path 3's gone. Where's my second bounce gone? Glitch alert. The lines are there, but the ends are in the wrong place. Has it changed its mind which intersection point it's going to use? Are you kidding me? Right, I'm not worried about the animation for a moment. Where's my second bounce gone? Oh, it is there now. Okay, so I did need to change it. So segment, it's the ends. I've changed it to intersection 2 and it's now working, whereas I just did. Whereas the other one, ends 2, is intersection 1. I don't get it. Is it just working left to right? And no, but and it was working fine and it just disappeared. I'll have to watch the video to see when that disappeared. Now the max path is 7.51. Let's make T depend on that. Let's do max path plus 1 just to be safe. And now I've got that bouncing off. They've gone horrible. I never sorted them out, did I? And we should rename it. All these fiddly code things. Partial paths 1, partial paths 2. Let's make them. In fact, let's hide the paths that are now working, and let's make these look nice. I could just do them all in yellow for now, right? And make them. And I should do number 3, but 2 steps at a time. Why break a habit? Go on, light bounce. Oh, I like it. I need to do the second bounce, but that's kind of doing what I wanted. Of course, if I drag T way off the screen, most of that T is going to be irrelevant because it's going to take a while, but we'll sort that out later. Let's get the second bounce. I think I've got a plan. So partial points 1, partial paths 1. Let's do partial points 3. And that's going to be zipping. It should be doable now, right? It's going to be a point on an object P with parameter. Oh no, I've got to do this time compensation thing. So what did we do last time? We did T minus S I used, but I need to get the second path as well. So let's do R scaled by the new path, and I need to reference several lists. So we're really using the zip command. I'm pleased with that. First, no, so we're going to use paths 3, but S needs to be from paths 1 to get the endpoints of that, and R needs to be from paths 2. It's looking promising. Cool. Wow, they start earlier than I expected. This second, I guess that the first few bounces are going to happen really quickly at the sides. Okay, let's check the paths. So partial paths 3 is going to be a zip with a segment from P to Q, and P comes from end 2 now. Q is the list I just made. It goes to partial points 3. And that is the other bounce. Again, let's make that look better. So we went yellow, and let's make it and we can actually animate this because we've got some limits on this. This is going to fly in, it's going to bounce off the sides and make that first a shape. But then the second bounce is already beginning to happen, and that's the second bounce shape. Right. Last thing, if I make a way off the side, like minus 100, that time is, most of that's irrelevant. Really okay, but it still works. Okay, I just need to limit the time to be, like, where does the light start appearing from? I guess roughly the side of my screen is -3, is it? Is it? How do I, wait, it's the x coordinate of A, but it's got to be negative. So that's now 100. Minus whatever I want to start at. Let's try 3. I'm not quite sure of my logic there, but that is kind of doing it. So literally, where's the graphics axes? Oh, the axes are black. Helpful. Graphics view, show axes, color, great. Yeah, so -3 is there, and that is, I think, where my timer starts now. Okay, good. It bounces in, or it comes in, it bounces, makes a shape, bounces again. And now animating T, I can start that slightly off the screen and it will bounce over there. So this is making our nephroid shape, and then the second bounce, whatever that is. I haven't worked that out. And I guess I want this to not bounce. Let's just go increase. And then it can appear again. Nice. And if I bring A back into the screen again, let's go -2. Will that mess up my system? No, because it's setting T to have a minimum of -1, so it just doesn't start until I hit there. That's all right. Yeah. Okay, we've built an animated caustic creating circle, simulating a coffee cup or anything actually which reflects light off a circle, and we're getting 2 bounces. And I think now I've got the process, I could get the third bounce in there. I wonder, thinking out loud, if there's a way of sort of using scripting to build these series, like the next bounce. Basically, we have a slider for a number of bounces. I could make them manually and make them appear with a slider, but I wonder if I could sequentially build them. It feels like I could, but it might be hard, and I'm already really pleased with this. So if we crank up the display and animate this in, we can see actually the light coming in and bouncing. Turn off the axes, don't need them. Nice. I've made it all the same color in this, but we could go back to our full view, turn off these partials, and go back to the paths. I'm puzzled about the intersections. I'm choosing to ignore that, as I said at the beginning, and that's the sort of full thing without the animation. Okay, I hope that's been useful. I enjoyed making this, and I've actually made it differently to how I did it when I built the file that I showed Brady, but the principles are the same in the background. And if you've enjoyed it, stick around for another video on this channel sometime soon of me building more mathsy stuff in Geogebra, or possibly other things, who knows. I'll see you then.